Dear students, myself Dr. M.K. Goyal. We shall take the lecture of KAS 302, Statistical Technique, Module 3, Applied Science and Humanities Department. I shall take the lecture of KAS 302 for Module 3. We shall discuss the topic of regression analysis. The important concept for this, we have to establish the relation. What is the regression? What is we use the regression? Why, how to use the regression analysis in this topic. First, we shall tell the correlation and regression. That is a very important relation, that correlation and regression. Correlation analysis determines the nature and degree of correlation between two variables. First, there are two variables and how much they are strong, their relation between them. That means there are two variables. Among the two variables or more variables, how they are related, how much is strongly related, they are positively related, they are negatively related, they are any other related. We have to establish and we have to study in the correlation. But our topic is here regression. The regression is estimated or predicted to unknown values of one variable, that and to get the another variable value of. That means if x is known, y is to be calculated. Y is to be calculated. If y is known, x is to be calculated. That means if there are two variables, x and y. If one is known, to get another which is unknown, is to be studied in the regression. That means regression is the estimation or prediction for unknown value of one variable from known value of another variable. That means there are two variables, if x and y, then we have to make a relation between x to y or y to x. Regression analysis enables us to determine a function relationship between two or more related variables. If there is a relation x, y and z, then we have to establish relation x and y, y and z, x and z. That means that comes into the category of multiple regression. That means there are more than two variables are coming at a time. Then we have to establish a relation between x and y, y and z and x, and x, y and z. These are internally related, and that is to be studied in the regression analysis. It is to be noted that just like curve fitting, the form of the function should be known by the least square method. We have to establish our relation with the method of least square method. That means we have to establish the relation of normal equation. Normal equation we have to find. Then we have to find the value of the constant, and the constant value of, to obtain the value of the curve to best fit it. The only fundamental difference, if any, between problems of curve fitting and the regression is that the regression any of the variables may be considered as independent or dependent, while in curve fitting one variable cannot be dependent. That means the curve fitting is a part into the category of regression, but every curve fitting cannot be come into the regression. Now let us take the linear regression. There are two types of the regression. First is linear regression. Other is multiple regression. Linear regression, that means a linear regression attempts to model the relationship between two variables. If x and y are given, x and y, then we can relate the relation. If x is unknown, x is known, y is calculated. If y is known, x is calculated with the help of linear regression. With the help of linear regression, we can relate the weight. If there are the equation relate data, weight and individuals of the height. If there are two variables, height and weight, if we are denoted as x and weight is denoted by y, then we have to find the relation between height and weight. Relation between height and weight is considered into linear regression. Linear regression. That means height and weight, weight and height. That means there are two variables. So we are studying in this category of linear regression. Lines of regression, if there are xi, yi, xii, yi is the general, I barabar 1 to n. I is equal to 1, 2, 3, 4 to up to n. Is the bivariate data. We are using the word bivariate data. That means in the pair of ordered pair. Ordered pair की form में लिख रहे हैं x और y 2 3 x is 2 y is 3 4 5. That is a bivariate data. We have to know reason or justification to assume y as dependent variable and x is independent variable. You can take the arbitrary value of x, then x is the independent variable, and we have to calculate the value of y corresponding to x. So x, it is become dependent variable. Either of two may be estimated for the given value to the other. Now we have the relation linear equation or linear regression equation of y is y on x. Linear equation of regression of y on x is given by y is equal to a plus bx. This is the equation regression line of y on x. Y is equal to a plus bx. A and b are parameters. We have to find out the value of a and b. We have to find value of a and b. Similarly, regression line of x on y. Regression line of x on y is given by x is equal to a plus by. X is equal to a plus by is called a regression line of x on y. There are the two equations, y is equal to a plus bx, another is x is equal to a plus by. These are the similar equations, but first equation is known if the value of x, if x is known, to calculate y, we have to use equation 1. Equation 1. If y is known, to calculate x, then we have to use equation second. That is the equation of line y on x. Y is equal to a plus bx. Second is x is equal to a plus by. There are a similar equation, but here the value of x is known and calculate y. Then we have to establish our relation y is equal to a plus bx by taking the equation y is equal to a plus bx in the form that x is known and calculate the value of y by the equation regression line of y on x. If y is known and calculate the value of x, then we establish our relation x is equal to a plus capital by, where y is known and to calculate a and b are parameters and we have to find the value of x. Now regression line of y on x is given by y minus y bar b by x, x minus x bar, b by x, x minus x bar. This is called regression coefficient. B by x is called regression coefficient of y on x. Similarly, regression line of x on y is given by x minus x bar bxy y minus y bar, where bxy is called regression coefficient of x on y, and b by x is also calculated by the relation b by x is also calculated by the relation r sigma y upon sigma x. R is the coefficient of correlation and bxy having the relation r sigma x upon sigma y. R is the coefficient of correlation, and on multiplication by these b by x into bxy is equal to r square. That means coefficient of correlation, and that is comes by the category of r sigma y upon sigma x into r sigma x upon sigma y, and that is cancel out and that is become r square. Then we have to establish bxy is equal to r sigma x upon sigma y and this. But the x and y are given, then the data is to be established by the relation. If x and y are given, then we have to find the relation. If x and y at bivariate data, then we have to establish our relation in terms of x and y. Byx and bxy can also be calculated by the table where x and y are given. That means the values are Byx is equal to n summation xy minus summation x summation y upon n summation x square minus summation x ka whole square. That is called Byx. That means the value of x and y are given. value of x and y are given. We have to find out summation x here, summation y here. We have to find x square, that is summation x square is here, x into y, and that is summation x square, x y is here. And putting these values, n is the number of sample size, number of samples. Putting these values, we can find b by x in this relation. We can find the value of relation by using n summation xy minus summation x summation y and summation x square minus summation x ka whole square. And b by x is called coefficient of regression y on x. Similarly, bxy is equal to n summation xy minus summation x summation y n summation y square minus summation y ka whole square. That means ki here the term is x square is known, xy is known. If we have to calculate y square, that means summation y square is calculated, summation y ka whole square is also calculated. Then means we have to calculate b by x and bxy. That is the coefficient of correlation regression of y on x. Bxy is the coefficient of correlation regression x on y. B by x is the regression coefficient. There are some properties of regression. Number one property, the correlation coefficient of geometric mean between two regression coefficient. The correlation coefficient of geometric mean between the regression coefficient r sigma y upon sigma x and r sigma y upon x is that means b by x into bxy, r sigma y upon sigma x into r sigma x upon sigma y, and multiplying this, and that has become r square under the root, and that has become r. That means geometric mean sigma x coefficient of correlation. Geometric mean between two regression coefficients. Geometric means between two regression coefficient r sigma y upon sigma x and r sigma x upon sigma y, then on multiplication that has become the regression of r square under the root, and that gives the coefficient of correlation. Second property, if one of the regression coefficient is greater than unity, then it must be less than unity. Since b by x, bxy is equal to r square, r having the value less than or equal to 1. That means ki b by x if greater than 1, then bxy is less than 1. Regression coefficient of greater than 1 of the 1, then other must be less than unity. That means कि दोनों की प्रोडक्ट r स्क्वायर के बराबर है, r की वैल्यू 0 से 1 के बीच है, इसलिए अगर एक एक से बड़ा है तो दूसरा दूसरे से छोटा होगा. The regression coefficient of 1 is greater than 1 unity, then other is less than unity. Third, both the regression coefficient and the correlation coefficient must have same sign. That means if we find the relation, find relation of correlation, relation of coefficient, that is correlation, correlation coefficient byx and bxy must have same sign. Must have same sign. Another property, arithmetic mean of regression coefficient is greater than the correlation coefficient. That means byx is the regression coefficient of y on x, bxy is the regression coefficient of x on y, and दोनों का arithmetic mean byx plus bxy divided by 2 is always greater than r. byx plus bxy divided by 2, that means arithmetic mean of regression coefficient is greater than the correlation coefficient. It is to be noted. These are the 4 properties we have established about the regression. Now angle between 2 regression lines. If there are 2 regression lines, then we have to make a relation between them. First regression line is y minus y bar byx x minus x bar. Y minus y bar byx having the value r sigma y upon sigma x, x minus x bar. Another equation is x minus x bar bxy y minus y bar. X minus x bar bxy is r sigma x upon sigma y, y minus y bar. That means byx having the value of this and bxy having the value of this, and we have to find, that is the m gradient. R sigma x sigma y have their usual meanings, their relation between the angle theta. Then we have the relation tan theta is equal to 1 minus r square upon r sigma x upon sigma y, sigma x square plus sigma y square for the relation. Now let us take slope of equation 1. m1 is equal to byx is equal to r sigma y upon sigma x. That is called m1. m2 is equal to sigma y upon r sigma x. That is m2. Since m1 m2 are inversely, दोनों की product byx and bxy having the property less than or greater than or equal to r square, equal to r square. If m1 is equal to r sigma y upon sigma x, then m2 is equal to r sigma y upon r sigma x. Then we have to find the tan theta having the relation m2 minus m1 upon 1 plus m1 m2, and putting the value of m2 is sigma y upon r sigma x, m1 r sigma y upon sigma x, 1 plus m1 m2 m1 m2 की प्रोडक्ट करेंगे, r से r कैंसिल आउट हो जाएगा, यह आ जाएगा सिग्मा y का स्क्वायर अपॉन सिग्मा x का स्क्वायर, 1 plus sigma y का स्क्वायर अपॉन सिग्मा x स्क्वायर. Putting this value and substituting and value of r sigma y upon r sigma x, r sigma y upon sigma x, 1 plus sigma y square upon sigma x square, and solving this we have the relation this 1 minus r square tan theta is equal to 1 minus r square upon r sigma x sigma y upon sigma x square plus sigma y square. That is the value of plus minus. That means m1 and m2 can be changed. So there we are taking the positive sign. R square is always less than or equal to 1 and sigma x and sigma y are both positive. If they are both negative, then it product must be also positive. So positive signs for acute angle, then theta is equal to 1 minus r square upon r, sigma x upon sigma y, sigma x square plus sigma y square. R is equal to plus minus 1. If r is equal to plus minus 1, then it is become 0. Then theta is equal to 0. Tan theta is equal to 0 means theta is equal to 0 or pi. Tan theta is equal to 0, 0 is theta is equal. That means there is a perfect correlation. There is a perfect correlation between two lines. That means they are coincide or parallel to each other. They are parallel to each other or either coincide. Either they coincide or parallel to each other. Second is, if r is equal to 0, then taking the value of this, tan theta is equal to 1 upon 0, that means infinite. Theta is taking as value of pi by 2. That means there is no correlation between line of regression, that is there are perpendicular. Since if perpendicular, m1 m2 is equal to minus 1. m1 m2 is equal to minus 1. Now let us take the example of regression coefficient of 0.8 and 0.2. What would be the value of coefficient of correlation? One coefficient is given as 0.8. Let us take byx is 0.8, bxy is equal to 0.2, and we know that byx into bxy having the product r square. That means 0.8 into 0.2 is equal to r square, and r is equal to 0.16, and r barabar under the root 0.16, that becomes 0.4. R must have same sign for both regression coefficient of byx and bxy, and r having the value of 0.4. That means positive correlation. If r having the negative value, then may be called as negative correlation. Negative correlation. Otherwise, we have to establish positive correlation. Now let us take the linear regression coefficient if x and y are given. The value of x and y are given 1, 2, 3, 4, 5, 6, 7, 8. Number of terms are n is equal to 8. Y are 3, 7, 10, 12, 14, 17, 20, 24. We have to find out sigma x, sigma y. Calculate x square, y square, xy. Now regression coefficient of byx is given by n summation xy minus summation x summation y upon n summation x square minus summation x ka whole square. And similarly bxy is equal to n summation xy minus summation x summation y upon n summation y square माइनस समीशन y का होल स्क्वायर. हमें क्या क्या चीज टर्म चाहिए? एक तो समीशन x चाहिए, समीशन y चाहिए, समीशन x स्क्वायर चाहिए, समीशन y स्क्वायर चाहिए, समीशन xy चाहिए. From these data of x and y. Now we are taking the value of x is equal to 1, 2, 3, 4, 5, 6, 7, 8. Y having the value of 1, 2, 3, 4, 5, 6, 7, 8. Y having the value of 3, 7, 10, 12, 14, 17, 24. We have find out summation x is equal to 36. Summation y is equal to 107. Now we have to find out the value of x square. X having the value 1, 1. 2 square, 2 having square 4. 3 square 9. 4 square 16. 5 square 25. 6 36. 7 49. 8 64. And therefore summation x square is equal to 204. Similarly, y square 3 having square 9. 7 having square 49. 10 having square 100. 12 having square 144. 14 having square 196. 17 289. 20 having square 400. 24 575. And summation y square is equal to 1763. And we have to calculate x and y. X and y is given by x into y. 1 into 3, 3. 7 into 2, 14. 3 into 10, 30. 4 into 12, 48. 5 into 14, 70. 6 into 17, 102. 7 into 20, 140. 8 into 24, 192. And summation xy is equal to 599. And putting these values in our bxy and byx. Now byx is equal to n summation xy minus summation x summation y upon n summation x square minus summation x का whole square. Putting these values in this relation, देखिए summation n is 8 into summation xy 599 minus 36 into 107 summation x and summation y. Summation x, you can see summation x 36, summation y 104. उसके बाद n 8 into summation x square. Summation x square is 204. Summation x minus summation x ka whole square. And the value of calculated is 8 into summation x square minus 36 ka whole square. And the value of putting these values, that is gained as 2.793. Summation x square minus summation x ka whole square. Putting these values. Similarly, byx के बाद bxy n summation xy minus summation x summation y summation y square minus summation y ka whole square. Putting these values in this relation. We have calculated byx is 2.79 and bxy is equal to 0.354. And that is become r is equal to 0.98 because byx into bxy is equal to r square, and putting this value of bxy is equal to this. If x and y are known as, take another variable example, if there are maintenance cost, y is 100 is given and estimate the value of x in the years. That means x and y are given as, and we have to calculate byx by the relation x bar is equal to summation x by n, y bar is equal to summation y by n, and that is become 25 by 5 is 5 summation y by n, 99 by 5 is equal to 19.8, and that is this. And equation is y minus y bar byx x minus x bar, and putting the value of y minus 19.8 0.95 x minus 5, and here we have to find out the value for x is equal to 4. Putting the value of x is equal to 4, we have find y is equal to 1885. That is a simple regression for the one quantity. Another variable is to be calculated for this. Or for the multiple regression, for the non-linear regression, we have to find polynomials, sequential, log, reciprocal or exponential. These are the cases to be calculated in the curve fitting for regression. And linear regression, these are the simple cases we have studied in our relation. Thank you.